Hello. Okay, there we go. Hello, Solomoon here, and welcome to my stream. I'm a game developer. I'm making stuff uh this renderer. It's a 3D renderer that I'm making from essentially scratch. Uh Largely, I guess you could say. Largely from scratch. It's kind of like PS1-esque in terms of its rendering capabilities, but you do have shaders and some niceties, some modern niceties. But overall, I'm a game developer. I've been making games and programming and stuff for a long time, and so here I am streaming some more stuff. This is no longer music creation with Renoise. That was old. That was an old thing, and I don't know how Twitch, like the dashboard, works. It's so many like tabs and stuff. Anyway, hello. Okay, so uh all right, so this is a little example I made of basically how you can do kind of like an engine kind of approach in Tetra 3D. I'm making a little helper package for this called Tetra Flow that basically creates an engine flow so that you don't have to do this yourself. So you can just be like, oh, here's where we instantiate like the game object type. For example, the player, the enemy, depending on the game object property in a node, which is this guy here. If we head over here to starting, and I'm sorry, I'm going to be a little short today. I don't have a lot of time. So I thought, well, I could not stream, or I could stream just for like an hour. So I figured I'd better, might as well just stream for an hour. So that's what we're going to do. That's what I'm doing. So basically, depending on the game object property of these cubes, they get turned into, or they basically get different classes instantiated. This is written in Go, so they're structs. They get instantiated, and all they have to do to basically implement the engine. I don't know why I keep doing like that, but all they have to do to implement the engine flow is basically implement either on update, on add, or on remove. So you can, for example, have something happen when a node gets added to the scene, have something happen every frame, or have something happen when the node gets removed. Might also be cool to make like an on timer, but while I can do that, I'm not sure exactly how that would work. I guess we could just add a timer system here, so you can access the timer system and then like schedule things as necessary. So I guess that's fine. We'll put that in here. Something like that, and then we can call update on the timer system here. Let me tidy this up. Let's get some music going before I forget. Let's go with this. Is fine, I guess. Somewhere around there should do, I think. All right, so that works. So basically, let's see. Current speed, timer. So speed is here. So we can fix that to be the time scale here, right? Animation time scale. Do we need? I mean, I guess we could just do like time scale and then let's see, update DT. Yeah, that's fine. I guess we can just make this scale general. And over here, speed equals flow by time scale. All right, cool. So this should work. Let's see. We could do is current time. I think we'll just do it like this. You do it like that, so you can't alter the timer system. Yeah, that's about right. All right, something like that. We use, yeah, okay. So this is the general idea is here. Because then we can just go and go to the player, for example, if we want to do something like, well, I'm wondering if we should even have an on-add function, because on-add is only called basically when the object has been added to the game scene. But there's no situation where an object would have the data be set but not be added to the game scene. Like if you add it to the game scene, then it will set the data. So that is by default an on-add function. So we're going to remove that because there's just no reason to. Then we don't need this. Let's see. So it's just updatable or removable. Okay, so model scene search tree pops up. Okay, let's give these guys some bounding boxes here. All right, then we just say player.model.get bounding ABB. Okay, then we say player.model.remove unparent. By parent props. Did I not? Oh, I don't have the, okay. Right, yeah. Cool, maybe. There we go. Cool. So you can have something happen when the object gets removed. You can have something happen when the object gets added to the scene because you're provided with the node and you set up the scene registry yourself. I wonder if there's a way to do this without having to do this. Okay, for now we'll leave this like this because I feel like this is pretty good. Registry function is a function to return something that implements ion update or ion game object component like. All right, I feel like that's pretty good. Flow, engine flow, flow, engine flow. Okay. Okay, well then why do we even have DT? I guess is kind of the question. Well, we should probably pick whether it has DT or not. Let's see. Okay, we'll go with this for now. We'll see how this works. Okay, so now we should be able to say I don't have, oh, this is readme.md. Cool. Okay. All right. Yeah, on collision might be cool, because then you don't have to check. How would that work? Well, I'll figure that out later. That could be powerful. Just simple on collision. Uh, okay. Collision checking, some others possibly, but this is fine. I don't actually have Tetra flow. Oh, I guess I have to do it. I wonder if I should do like Tetra 3D term. For now, this is fine, I guess. Let me just make a repository to hold this for now. Tetra. Okay, Tetra termed. All right, that'll do. Okay, so what we're gonna do now, we're just gotta basically, oh no. Reset commit, soft reset. Dang it, why did it? Okay, here we go. No. Okay, so this now exists. Cool. Cool. All right, so now we should be able to just go over here and basically make this work like so. I guess it wouldn't be used here, it would be used here. Okay, let's see. All right, so tetraflated flow. All right, so then we can just say reset. I think we can do it here. We don't have to do this. We can just say Tony says hello. Hello, how are you doing? Welcome to the stream. Excuse me, this was a banger. Keep that going. Let's see. Okay, cool. Player, all right. Enemy gets cheese. Okay, cool. Engine flow is this. That's fine. Means we don't need this. Let's see. Here we go. Okay. Okay, ion update delta. I don't know if I like that delta. We're passing the DT because it could theoretically change, but will it? Would it? Could it? It could, right? Flow without time plus equal DT. Oh. Oh, I see. Got it. Okay. So then this should work. All right. So then, yeah, DT, we can do DT. That's fine. All right. So this should be good. All right. So okay. So then we can go to find a website that gives helpful infographics on Go optimizations and other stuff. Oh. AI int v a dot int v yield a dot int handle assertion emits a single branch. Jump up, jump down, jump up. I see. Interesting. Okay, this is very useful. Yeah. To come back to that, come back to those. I'm running a little low on time today, so I'm like, let's go, let's go. All right, so we're gonna go back to main here. We don't need this guy anymore because we have one built in now. Clear. Oh yeah. Guess we could do something like that, right? End. Yeah. Then we Then we could have scene end and scene start. Yeah. Because it could. So end is only when the engine flow is destroyed. Okay. So now we're getting a little more cool stuff that justifies why this exists in the first place. Let's put this in TetraFlow. Yeah. All right, so yeah, we can say like on update, on remove, type I on scene start interface. Start I on scene end interface. We won't do scene restart because we don't know that the scene is restarting or not. I think. We'll just make a function. Flow and timer system dot clear flow dot individual timescale. Speed. Speed. And scene should not be changed. We could do a scene change. That's true. That's a thing, I guess, for README. Scene change. Other Okay, on scene start, end. Yeah, it's fine. Does this show up correctly? It does. Okay. Yeah. All right. On scene start and end. Oops. It should be as simple as this. If flow.time is 0. Okay, cool. And then we want to know scene start, scene end. The scene, it should have the pointer to the scene. That should still work. Update. Let's see. Flow.ended. Flow.ended. Then update does all this. Flow.ended is true. Flow.ended. Actually, do we need to call this? Because if it's ended, then it just stops updating, right? Yeah, I don't know if this is even good. Because, like, if you end a scene... Well, you might want to do something when the scene ends. So really, this is just a messaging system. With some sensible things. When the object is removed, when the object updates, when the scene starts and ends. I don't know. I kind of like the idea, but I kind of don't as well. This only really works if you can restart a scene. Which I think we could do. So we could do something like this. If we're gonna do this, we're gonna go hard into it, I guess. Shouldn't be able to edit this. Okay, so the idea here is pretty simple, I think. We will say started, it's also a bool, and then we say basically if flow.started, flow.scene equals flow.scene. Oops. This should be just scene. And then flow.started equals true. All right, so then you say if it's not ended, then you keep going. You can end it, and then when it's Okay, we can just say flow that. Yeah, that's fine. I'm gonna do. Oh no, where's this? Okay. Okay, so okay. Started. Okay. I guess we just do it like this, not anything about it. Just started. Floating on scene start, on update, on remove, on scene end. And then we can say flow restart if flow dot ended false. If flow ended, flow dot ended equals false, flow dot started equals false. Flow dot end equals true. On scene end. So we can just do this then, I guess. Or I guess if not flow dot ended. Flow dot end. There we go. So that we'll end the flow, and then we will, on the next frame, restart, update. This is wonky, but I think it should work. Okay, so let's go back and test this out. Nothing's working. Let's see. Oh wait, that won't work, will it? Because when it does this, when it clones it. Yeah, see the engine, like, you pass it a scene to clone, then you can't draw an update. You can't draw that scene. Okay. I'm thinking like we could, let's see, how will we draw in this engine? I mean, I guess you could just draw manually, right? Like, do you need the... Ideally, you want the scene. All right, I think this should work. I guess I could just... Okay, I guess we'll do something like this. And then we'll also do... Oh yeah, it doesn't have a camera. So we just have to, yeah, we just have to pass it. Unless we want to specify an active camera. No, let's not go too deep into this. So we could do something like this. Right, and then... Alright, so we put an update, and then we just say scene Gamedev. Okay, cool. So now the upside of this approach, you're dead, should be that we can just be like, oh, let's say we want, for example, new scene. Yeah. Now I'm wondering, like, I keep thinking like, man, maybe I should just make a messenger, but no, it has to have the engine flow in order for this kind of thing to work. Cool. Now, if we go back over to main, we can say restart, right? Yeah, or instead of this, we can say g.engineflow.restart. And it started. It's false, right? It started as false. Scene ended, scene start, you're dead. Oh, I see. We need to make a... So this should be the scene should be Tetra 3D.scene, and then this should be prototype scene. All right, prototype scene is this, and then we just say scene equals cloning the prototype scene. Cool. There we go, cool. So that works. Scene start, scene end. Yeah, cool. All right. But the thing about this, even though this works fine, I wish it was something that you could like intentionally override or not. Because like this approach, the problem with it, as you can see, is like it depends on you typing things correctly, and also it depends on you, like it's not really easy to refactor. Like if I go back and say like, oh, I want on scene start to like take the scene, you know, something like that, like there's no way to easily refactor this, and it won't like tell you there's an error. It will just stop running. This code won't run anymore. We don't want that. We want it to be like a hard coded kind of thing. So I'm thinking that we could design basically a type, like a game object, something like this, which is a struct that has functions that you can override. So you have on update, on remove, on scene start, on scene end. And then how would this work? So it would return. So it could actually embed the game object struct like this. Because then you can define these functions like this. Can't assign to on remove. Why can't? Oh, because there's two on removes. Yeah. So you can either define them here, or you can just be like, this is just player dot on remove. The upside of this is that now if we go back and we say like, oh, on remove takes like the scene property. Now this should no longer work. Yeah. Now it's like, hey, it needs to take a different argument, a different signature. So that might be the better approach. This also allows us to kind of cut down on this stuff. And it also makes it easier to implement because you don't have to like think that much. Like you don't have to be like, oh, what's the name of, how am I implementing this? What's the name of this thing? You can just be like, you know, here we go, like this. This could just be like that. So you just say like, oh, on update is player dot. I guess you would do like this. Something like that. So now you can take these out of here. But no, now that I think about it, this doesn't work because it doesn't. This is not this. Well, no, this should work. Because the registry option function should be able to return an object that implements game object. Oh no, that won't work. Like the downside of this is so specific. What's another way to do this? Like it would be nice if you could make it like a just write like implements, like player, like you say like func player, and then just implement. Yeah, implements. Yeah, whatever. And then it would like just write the code to make it implement it. But that, let's see. How do we make this better? Ideally, I want it to be just kind of like automatic. But I can't think of a way to make it nicer, so I think that this might be... It's either magic and it breaks when the magic goes away. When the API changes, the flow breaks. Or the API changes and the flow lets you know it's changed, but it's just very awkward. Because I think if I go this route of basically doing something like this, this won't work because it could return the game object. Actually, you could do that. You could return the game object. It doesn't even have to actually be here. It doesn't have to be in the player thing, because if the functions are the same, if you outfit it like this, and you can also define them here, then you can refer to the player struct, and these functions would modify the player struct, and the game object basically would run those functions on command. So the game object, so that could actually work. Okay, so that's, let's see how that looks. So basically, game object can just be, doesn't have to be a pointer. So all of these are always game objects. It's okay, then you can append that. Excuse me, data registry function should just return a game object. New engine flow, okay. Cool. I guess it could return a pointer to a game object. Because then the data can be nil. We could make the game out. Well, we'll just make it a pointer just to make it easy. So then we just say if just started. Then this is, we know that this is game objects, right? We know that these are pointers to game objects. And then we can just do this. pointers. Oh, but no, we need pointers to the node for the animation player. Okay. Okay. All right. So, all right. So then G, these are nodes. We already know that it is a game object though, so we can just say g.data.gameObject. Scene. There we go. All right, on remove. Okay, and then so that's the idea. So now we can go back over here, and it should be as simple as this. We don't need this. We can just return this. On remove is player dot on remove. Start on scene end, player dot on scene end. Okay, cool. So now the upside of this approach is a little wordy, but the upside of this approach is that the API is kind of fixed. You can rename things as necessary if you want to have something not, if you want to have the update function be called something else. Like this, update instead of on update, you can do that. And it's no big deal. But these functions still manipulate the player data, so that all works. Is it really worth all that? I mean, the upside of doing it the other way is that it's super simple. On scene start, on scene end, on update, on remove. But the upside of doing it this way, the downside of doing it this way is that it's kind of awkward. What if we made just a message function? It implements the message function, and then it gets a variety of messages like scene start, scene end, on update. So all of these are one function. That way you can ignore them more easily. We can turn these into like constants. It's not a bad idea. So basically you get a variety of messages. That's not a bad idea. Because that way, this is simple. You basically just have one function on message, and then you're basically dispatching or dealing with those messages. That might be cool, because then we could also make a messaging system within the engine flow where you can message other game objects freely. You could say engine flow.message and create a message that kind of is cool. That's kind of elegant. It kind of condenses both concepts together. It's not perfect, but I think it is a good idea. So instead, you have basically game object is an interface. It just has a receive message. The message is a message, which basically has a payload or data. And then an ID, which can be an int, or I guess we could say message type is an int. We could say like update, message type, iota, and then you could say on update, on remove, on scene start, on scene end, like that. Then creating a message is as simple as just creating an ID and putting data in there. And then you can basically have the engine flow send a message to game objects to tell them to do things. That kind of covers a variety of things. I like that. It's a little elegant. It's not perfect, but it's a little elegant. Running a little low on time, so this is going to be it, I think. So the general idea is this. So we just return player. It is player. We return player. That's fine. And then we just say player on message. All right, it's receive message. Message is message. There we go. We can switch message dot ID, or I guess you can say type. Case scene start. Type. All right, there we go. And so that's the general idea. So we can say now this would be. We already know that this is a game object, right? So we can just say g.data.game object. Receive message type message, or I don't have, yeah, let's see. There we go. Message type on scene end, data is just the scene, flow.scene. There we go. So now you can also say flow send message game objects g.data receive message. Lachi says another stream. Woo. I'm about to leave actually, unfortunately. I'm really low on time, but I came up with this engine flow idea that seems to be pretty good. I like this idea and I think it'll work pretty well. But yeah, I gotta go, like, really I have to go now, but I wanted to just type this out. Oh, this should be that. No dot data dot okay. Message. Okay, cool. So you can say, give it some targets. Oh, I said scene. Send a message. Targets. Cool. All right, so this is an idea. We'll see if how this works. It's just game object. Okay. So data just started. Receive message. Message type on scene start. Wrapped up in a cozy blanket, watching us solar loon steam with my. I don't know what. Well, I'm happy that you're having Blahaj soft toy, a plush toy. Okay. Watching a solar loon stream, what could be a better morning? All right, I'm glad you're having a nice time. I'm glad you're chilling. Message type giant stuffed shark. Of course it is. Okay. P.data receive message. This would be remove. Cool. All right, so remove, update, scene start, and scene end is down here, right? Yeah. Cool. All right, so this is pretty cool. I think this will work. Let me see. What is that doing? It's casting it as a game object. Yeah, that's correct. That's exactly correct. Oh yeah, that should work. Game object. There we go. Nil is valid. So this should be I game object. Enemy does not implement. Okay, because it needs to on message. Cool. Once. Okay, so I'm just doing like this just to see if this actually works. All right, we'll see if this works. Should work. Scene start. You're dead. Scene ended. Scene start. Dead. I'm not sure why it says you're dead again. You're dead. On remove. Scene start, scene ended, scene start, you're dead, scene ended, scene start, you're dead. On remove, where it is on remove. If it doesn't still exist. Oh. But it's not ended. If it. Okay, well ended is true, so then let's say flow dot game objects equals yeah. So I think it should work. Okay, you're dead. Scene start, scene ended. Scene ended should happen for scene ended. Scene ended. Ended equals true. I feel one could describe Go as a functional language with object-oriented shortcuts. Scene start, scene ended, scene start, scene ended, scene start, scene ended, scene start. Okay, I think it's working. So yeah, this is an interesting design, an interesting approach, because I'll have to go, but the general idea behind this was I wanted something that was kind of like something like an engine flow, because that's something that, if you're making a game, even if you're making it from scratch, you're going to have an engine flow of some description. This basically tries to do something so that you have a flow of some description. My approach originally was to go the interface route, but the problem with the interface route is that if the API changes, then that's no good, right? So like if I make it so that, on scene start, we don't take a scene argument, on scene end, it doesn't take a scene argument, and then I change the API, now all of a sudden your game just won't work. It's not going to just require you to refactor, which is a little bit of a pain to begin with, but it's, in addition, it's just not going to work anymore, which is like, that's bad, right? So then I was like, okay, well, what if we like make a game object basically a collection of functions that you point to functions on your object. So for example, on update is, a function, and then you can point that to your own player's on update function. The problem with that is it just has this additional like blob that doesn't really make sense. And it's just kind of awkward to just have a blob that's just like, oh, we're basically returning a game object, and it's kind of weird because you're basically returning a game object and passing functions that point to the player's functions, and then they operate on the player pointer, so it all kind of works, but it's a little weird. So then I'm like, okay, well, what if we went this route where we basically, in the flow of an engine, are dispatching messages, and all you have to do is to implement receive message to allow yourself to receive messages from the engine, and then you just basically switch off the ones or implement or do something on only the message that you care about. This is, I feel like, a little bit of a better approach, because this allows, it's not perfect, but this allows you to, for one thing, only implement the things that you want to implement, which is important. It should be resistant toward API changes. So for example, if, what is going on here? Okay, I'm not sure why my phone just started picking up my voice. It's resistant to API changes. So for example, if I rename message type on scene start in my API, all I have to do is just rename it here in the rest of my code. If I implement something like a change in data, I can, let me think. If I implement a change in data, I might want to make this some kind of like strict thing. Maybe I'll make different message types for the built-in messages. So you can just switch off the message type. Because I'm thinking like, how would you know what the message type for these is without having to examine the code? So it's like, we don't want to make it overly complex. But yeah, the upside of that is basically it's kind of simple. You don't have to implement the things you don't need to implement. It's resistant to API changes. And maybe best of all, you can make custom messages. So if you want to make a game where, let's say, you have API, or rather AI that, like NPCs that are walking around or whatever, and then you put down a bomb and you're like, oh, I want the NPCs to run away from the bomb, right? I want the enemies or the player, not the player because he's controlling it, but the enemies or whatever, NPCs to run away from a bomb. I can just basically send out a message. I can put down the bomb and then just ask the flow, hey, please dispatch this message to everybody, to all of my target target nodes, which you can specify and just be like, grab everybody or grab all the nodes within a certain distance, and then the engine flow will just be like, hey, are you something that can receive a message? If so, then here you got a message saying that there's a bomb. So that's a very simple and straightforward approach, kind of component but not overly complicated. And we can easily extend this to basically have built-in messages for simplicity, for like built-in messages. You can, or we can extend that. I can extend this to have built-in messages for simplicity, for working with the built-in processes of an engine, and then custom messages can also be there as an additional thing. And then if you want to not have everything in a single receive message function, then obviously you can just switch off of these and call the player relevant function. So make a function for the scene start, make a function for the scene ending, make a function for update, and then just call those functions from here. So I kind of like this dispatch method approach. It's a little weird, but I kind of feel like it could kind of go crazy. I don't know. It could kind of go crazy in a good way. It feels like it's not overly complicated. Because the interface implementing approach, I like implementing interfaces in Go, but it's so lax and loose that I wish it were more hard coded, where you say like, oh, here's my struct and it implements this interface, and then if it stops implementing the interface, now there's a problem. Like, there's no way to do that, because whether a struct implements an interface is just whether there's a function that operates on the struct with the same name. So if the name changes on the API, now your object no longer implements it, but it won't. It's not an error. That's the problem. It's not a bug. It's not an error. It just stops working. I don't want that to happen. I feel like that's kind of a bad approach. Whereas now, if I, for example, change this in the API, then when you try to run your game, it's going to be like, no, this variable doesn't exist. Or when you try to cast a, update message to, or rather a scene start message, like data type to, the wrong data type, because the API changed, your game will crash. But that also should happen, before your game crashes, because the API changed. Anyway, I want to make it as simple as possible while also being kind of like smooth. This feels both like it's smooth, but also it works. I don't like that everything is together in the same message, like, all here. But again, it's not too big of a deal to just kick this out to a function and then just call that function. Means less immediate spaghetti, but following usage could be a bit harder, could be very easily expanded on. Yeah, I feel like, and that's the idea too, is I was going to expand it for like collision checking and stuff like that as well, where rather than manually checking for collision, this engine flow could do it, where basically it just says, hey, all the bounding objects, check all other relevant bounding objects, I guess. I'm not sure exactly how I would do that. But I would like to have some sort of collision pair system where you can check to see, like, am I touching something and what am I touching? And just get some basic data. That'd be cool. Because then you could switch off of that. And so, I think maybe leaning into messages might be a little stupid, but at the same time, I think default does the same thing. I think it's very message heavy. And Godot, I think also it kind of has a, kind of leans on messages when it comes to signals. So it can work. I'm just not sure if this is a good approach, but I don't feel like it's a bad approach, because there's only a few message types, and I don't think there'll be more than just a couple. Maybe one for collision, maybe one for restarting a scene instead of just starting and ending. Maybe, I don't know, but I think this could work. I think this could work really well. Yeah. All right. Well, thank you very much for watching. I'll just stop it here. I got to get going, but it's been real. I'll catch you guys on the flip side next time. Tomorrow, maybe I have to see what time tomorrow. But definitely Wednesday, possibly tomorrow. And, by tomorrow I should have this a little bit more clean and a little bit more, what's the word? fleshed out. There it is. All right. Thank you very much for watching. I'll catch you guys on the flip side next time. See ya.